Welcome to everyone. So now starting the next problem for this friction. Okay, so see, the next problem is what? Here it is given that determine the force P required to intend the motion of block B as shown in figure. So that means what? A force P is applied this direction, right? So this is A block, B block, and below it C block, right? So see, so in the figure, so take mu is equal to 0.3 for the surfaces of the contact. So now you have to know one things, that is what, try to understand the concept. For example, suppose if I consider that this is just see, the pen is kept on this wooden surface, right? Now suppose if you move this wooden surface this direction, just see, just if you move this wooden block this direction, just see here once again. So which direction the pen is moving? Opposite direction. Again, just see these things. If the pen is now at rest, so no force is acting on this pen. Suppose if you suddenly move this wooden block, so see, so pen is moving this direction, right? So friction is acting which direction? This direction. You are moving this wooden surface this direction, so frictional force on this pen is acting which direction? This direction. Because try to understand, because see, so why the pen is moving this direction? Because the pseudo force is acting this direction. So frictional force is opposing the motion of the pen. So that means what? Frictional force is acting on the pen this direction, that is the direction of this wooden block, right? So that means see this. Now I am coming to the question, that is, see, this is the B block, and on this B block P forces is acting. So see, A block is above the B block, right? So if I consider the free body diagram of A block, so what is this one? See this, just try to understand. This is the B block, right? This is the B block, and see above here this one is the A block, right? And I have to consider the free body diagram of the A block. So see, at first try to understand here P force is, just try to understand, P force is acting on the B block. So A block, a pseudo force is acting which direction on the A block? This direction, right? And frictional force on the A block by B block will be which direction? This is the frictional force on the A block. Small fa I have written here, and small fa will be what? So that means equal to, this is the reaction force on A block by B block, so that is the RAB, and FA, that is the frictional force, will be your mu into RAB. Okay, next one is what? So another one is your weight of the A block, right? Weight of the A block is equal to WA. Okay, so if you can understood this one, so see, so I can write here, so net force acting along A block is what? So that is Fy. If I consider Fy, so Fy is equal to what? RAB, see, RAB minus WA is equal to 0. Okay, so RAB minus WA is equal to 0. So you can easily write which things? You can easily write that RAB is equal to WA, right? RAB is equal to WA. So if you can understood this one, so now I can write WA is equal to how much? That is the 300 Newton. So 300 Newton I am writing. Okay, so see, next one, this is from the free body diagram of the A block. Now if I focus the B block, now FBD of B block, so this is the B block. So see here, this is the B block. Okay, this is the B block. and see what is how much forces are acting on this B block. So see, one force is these directions, that is the P force, it is given. Another one is try to understand, see, on a block by B block, frictional force is acting which direction? This is mu RAB, this direction, right? So same way, this A block will exert frictional force on the B block to resist the movement of the B block this direction, right? So this is your, on the B block, this is equal to mu RAB. In the same way, C block, between B block and C block there is a frictional force will be acting, that is what, that is will be these directions, right? That is will be your this direction. So this F is equal to mu into R, here I am writing RBC. So see, RBC means what? See, here I am drawing what is this RBC. So same way, C block will exert a normal reaction on the B block, so this is the RBC. Another thing is what? Weight of the B block is WB, and see, RAB, because see, RAB means what? A block will exert a force, a normal force on the B block, that is equal to your what? RAB, right? Right. So this is what? Actually this is RAB, this is RAB. So see, here I have written like this way. Can you understand? Again I am explaining, again I am repeating. This is the B block, okay? P force is acting these directions. So see, on A block, frictional force is acting this direction, and this frictional force is exerted by which block? B block. Same way, A block will give a frictional force on B block, which direction? Opposite direction, right? Because to movement of this B block, okay, this one. Same way, C block, I mean this frictional force is by the C block, right? That is equal to, this is by the C block, right? So this is equal to FC is equal to mu RBC, okay? Normal reactions by the C block is equal to RBC, and all of you know the weight of the B block is there, that is WB. And see, RAB, this RAB means what? This is the normal reaction by B block on the A block. Same way, A block will exert its normal force on the B block, that is the RAB. Same way, if you consider this is action, this will be your reaction, right? So because here I am considering on the B block, try to understand the things on the B block. On the B block, how many forces are acting? That is RAB. So see, if we consider the total forces on along y axis, that is your 0. So see here, if this mu RAB is acting positive total forces on y axis is equal to 0. Sorry, here I am considering the y direction. So RAB is acting negative y axis, WB is acting negative y axis, and RBC is acting positive y axis. So I can write here RBC, okay, minus WB is equal to R minus RAB. So that is equal to what? RBC is equal to 0. RBC is equal to WB plus RAB. Okay, I hope you can understood. So total force along y axis is equal to 0. So RBC minus WB minus RAB is equal to 0. And same way, if I consider this is your equation number 1, okay, and see here, okay, from the 1 you can easily write the value of RBC. So see here I am writing the value of the RBC. So see, WB is equal to what? Given WB is equal to weight, that is 500 Newton, plus RAB means what? 300 Newton. So I am putting the value. So you are getting what? 800 Newton. So this is, you can put as equation number 2. So RBC value, okay, RBC value is equal to 800 Newton, right? So now if you can understood this one, so next if I consider that suppose if I consider the x direction, so x direction, how many forces are acting? See, if I consider x direction, so see here in x direction, if you observe, this is acting negative x direction, so I am writing minus p. These two frictional forces acting positive x direction, so I am writing plus mu into r ab, mu into r ab plus mu into r bc is equal to 0, because total force acting along x direction will be 0, because if the system is in equilibrium. So it is equal to what? It is equal to P is equal to, you can easily write mu into RAB plus RBC, right? These things you can easily get. And see, already you have find out the value of RAB. RAB is equal to your 300 Newton. You put the value here. Mu value is also given, because mu is 0.3 for all the surfaces. So I am writing here 0.3, and RAB value is equal to your 300 Newton. I am putting 300 Newton, and RBC, see RBC, recently we have find out that is 800 Newton. So that is 800 I have put in, right? So what is the value you are getting? You are getting that 0.3 into 1100, okay? So that is equal to, if you calculate this one, this is 3 by 10 into 1100, so this is equal to 330 Newton. So this 330 Newton force is required, okay? So if you can understood this one, okay? So next, see the next problem, okay?